All right, good morning, good afternoon, and good evening, everybody. Today we're going to start talking about probability. So, probability is a very important concept for us to understand mathematically, and it's a really great application of real world math. This is something that we definitely see a lot of. So, what does probability mean? It's the chance that something will happen. So we hear about probability when we talk about the probability that it's going to rain during the day, or when we talk about the probability that you're going to win something. So we see this as the chance that that event will occur. So some event, whether that event be that it's going to rain or that you're going to win. So we can determine by dividing the number of ways that it can happen by the total number of outcomes. So what we're going to have is we're going to have a number which will be a fraction or a decimal, and it's always going to be between 0 and 1 because the number of ways it can happen can't be more than the total number of outcomes. So for example, rolling a die, I can't have more than 6 ways for something to happen if there's only 6 sides on the die. So our probability will always have a smaller number in the numerator over a bigger number in the denominator, giving us that number between 0 and 1. So a certain probability is when the event will absolutely happen, and that means our probability is 1. So for example, when you roll a die, the chance that you will get a number, right? So our die will have the numbers 1 through 6 on it. So all 6 sides are numbers out of the 6 total sides. So we get 6 over 6, which is 1. So a certain probability is a probability of 1. It is definitely going to happen. An impossible probability is when the event will not happen, and the probability in that case would be 0. So if I were to roll a normal die, the probability that I get a letter would be 0 because there are 0 letters on the 6 sides of the die. They're all numbers. So 0 out of 6, giving us 0. We can also talk about how likely or unlikely something is to occur. So since our numbers for our probability will always be between 0 and 1, the closer the number is to 1, the more likely that event is to happen. So for example, if I were to have a probability of like 0.9 or let's say 0.85, right? So those are probabilities that are closer to 1, they're more likely to happen. An unlikely probability would be closer to 0, and so it's less likely to happen. So something we could have like 0.05 or 0.12, right? Because those numbers are closer to 0. So the closer we are to 0, the less likely it is to happen. The closer we are to 1, the more likely it is to happen. And all of our probabilities will fall on some sliding scale between 0 and 1. So what's in the middle, let's think about that. That 0.5 would be our 50-50 chance of something happening. So like flipping a coin. So it's not that one side is more likely than the other. They have that equal probability, right? So 50-50, 0.5 is halfway between 0 and 1. That either a head or a tail could occur. All right, so let's talk about how do we calculate these probabilities. So some, to be honest, are way more intuitive than others. So things like flipping a coin, most of us can think about that there's, a heads or tails, and that we're going to get that 50-50 chance. We can also talk about things like rolling a die, and a lot of times you'll see situations where you're like picking something out of a bag, like marbles or candy out of a bag. Right, so first example here, the chance of rolling a 4 with a die. So we have to think about how many ways that can happen. So with a normal die, we're going to have 6 sides, and they're going to be the numbers 1, 2, 3, 4, 5, and 6. So the number of ways it can happen, there's only one way that it could happen, that we're going to land on that side with a 4, out of how many different ways that we could, or how many different outcomes we could have. Well, we have 6 sides on the die, so there's 6 different outcomes. So our probability in this case is going to be 1 out of 6. And we can write that as a fraction. We can also write that as a decimal. 1/6 comes out as a repeating decimal, so it's actually a little bit easier for us to leave it as that fraction. All right, so for our next example, so there are 5 marbles in a bag. 3 are blue, 1 is black, and 1 is red. So I want to know what is the probability that a red or a black marble gets picked. All right, so let's think about this. So in our bag, so we'll do this out. So we have blue, blue, blue. And then I have one that is black, so I'll use BL for black. And then I have one that is red. Okay, so we want to pick a red or a black. So we would be a success if we pick a red, or if we pick a black. So what is the probability that red or black marble gets picked? So the number of ways it can happen, we have two options. We can pick that blue marble or the red marble. And then there were how many different marbles that we could have pulled from the bag. So when we reach into the bag, there are 5 different outcomes that we could have gotten. We could have gotten the blue, 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 the black, or the red. So there's 5 different total outcomes in pulling a marble out. So what is our probability? It would be 2 out of 5. One of the things that I personally really love about probability is that you are always a winner. So when you're calculating your probability, you're assuming that you're going to have success. So you're going to assume I do get the black or I do get the red marble. Okay, so we're always going to assume for probability that it is success, that we are winners. All right, so next one. We again have the 5 marbles in the bag. 3 are blue, 1 is black, and 1 is red. We want to calculate the probability that a green marble gets picked. Now, if you're sitting there going, I think Mrs. Murphy has lost it, well, you're not wrong. There are no green marbles in that bag. So how many ways could this happen if there are no green marbles in the bag? 0, right? There's no way that I'm going to reach into that bag of 5 marbles where 3 are blue, 1 is black, and 1 is red and pull out a green. It cannot happen. And our total number of outcomes of reaching into the bag and pulling out a marble, I have 5 different things that I could have pulled out. So our probability in this case is 0 out of 5. So again, if the number of ways it can happen are 0, that gives us a 0 probability, which if you remember means it's impossible. There's no way I could reach into that bag and pull out a green marble. All right, number 4, there are 5 marbles in a bag. 3 are blue, 1 is black, and 1 is red. We want to know what is the probability that a red, black, or blue marble gets picked. So again, let's think about this. We had 3 blue. All right, so blue, blue, blue. We had 1 black, and we had 1 red. I don't think that's red. There you go. All right, so what is the probability that I could pick a red, black, or blue? Well, any marble that I pick is red, black, or blue, right? So I have 5 different ways that I could be successful here. And there are 5 different marbles that I could have pulled out. So my probability is 5 out of 5, which is 1, so it is certain. So if I reach into this bag of 5 marbles with 3 blue, 1 black, and 1 red, it's impossible for me to pull out a green, but it is certain that when I reach in, I will pull out either a red, black, or blue marble from that bag. All right, so let's look at some more examples. All right, so Leanne collects data throughout the baseball season and uses these data to determine the probabilities of different teams playing in the league championship game. The probabilities of her 4 favorite teams playing in the championship game are shown below. So for the Tigers, the probability is 2/3. For the Redbirds, the probability is 4/5. For the Bulldogs, the probability is 3/8. And for the Titans, the probability is 1/2. And we want to know here which team is least likely to play in the championship game. So we have to remember that our probabilities are always going to be between 0 and 1, with 0 being impossible and 1 being certain. So the least likely, we want our answer to be closer to 0. Excellent. Now, for all these fractions, they have different denominators, so the best way to compare these numbers would be to look at them as a decimal. So I can use my calculator. I can do 2 divided by 3 to get 0.6 repeating. I can do 4 divided by 5 to get 0.8. 3 divided by 8 to get 0.375. And I can do 1/2. I could do 1 divided by 2, or we know that that is 0.5. So which one is the least likely to get in the championship game? Which one is the closest to 0? And that's going to be choice C, the Bulldogs. All right, number 2. So this one's got a lot of information here, so let's read really carefully. A researcher surveyed 5 randomly selected employees from each of our 4 different companies about their daily commutes to work. The table shows the commute times for the surveyed employees. So in our first column here, we have the amount of time for company 1 in minutes. So the 5 employees, there was 24 minutes, 26 minutes, 28 minutes, 23 minutes, and 21 minutes. In the amount of time for the company 2, so I'm in this one, there was somebody who took 6 minutes to get to work, 32 minutes, 9 minutes, 31 minutes, and 21 minutes. And for company 3, so that's our third column here, all of their employees took 15 minutes to get to work. Very unusual. And then for the last one here, we have for company 4, the first employee took 13 minutes, then 10 minutes, then 45 minutes. They got a long commute, 12 minutes and 15 minutes. So we want to know, based on the data, which company is most likely to have the longest average commute time per employee. So I have to think about, if I were to average these numbers out, what would my average be, and which company, if I were to pick it, is most likely to have the longest commute time. So what I can really think about here is for company 3, we know that the average there would be 15. But then for my other companies, I could look at which one I would expect to have the longest average, right? So even though in company 4, we have that person with 45, the other ones are pretty low. So that's not going to change our average too much. It will bring it up a little bit higher. But if I were to randomly pick someone, that would probably be more likely to pick someone with those 10, 12, 13, or 15. Right. With number 2, again, I do have some longer ones, but I also have some shorter ones. So there's, not a good chance that I'm going to pick someone with a long commute time. But with company 1, most of those have longer commute times. So there's a good chance or more likely, right, that I would pick somebody with a longer commute time. So company 1 is the most likely for that to occur. All right, which number represents the probability of an event that is very likely to occur? So this one is really straightforward. I love questions like this because what I have to remember is that very likely on a scale from 0 to 1, the very likely is going to be closer to 1. So I want to be between 0 and 1 and closer to 1. Well, choice A, 0.12 is close to 0. Choice D, 0.09 is even closer to 0. So now I'm down between B and C. Now, a lot of students are really tempted to pick choice B with that 1.3 because although 1.3 is closer to 1 than 0.9 or 0.89, unfortunately, this is bigger than 1. Or actually here, I'll use my inequalities, that this is greater than 1, and I can't be greater than 1. I want to be between 0 and 1. So that's actually going to be out, and it's got to be choice C. So that one's a little tricky for us here. All right, for our next example, a computer program selects blue, red, or green as the background color each time the program is used. So when we pull up the program, it's either going to come up as blue, red, or green for our background. The program was used 45 times on the same computer in 1 week. Of those 45 times, a blue background appeared 12 times and a red background appeared 21 times. So when we ran it to get blue, it came up 12 out of the 45 times. For the red background, it came up 21 out of the 45 times. Now, based on this information, which statement about the likelihood or how likely something is to occur of the green background appearing the next time that the program was used? All right, so let's think about this. To get a background, it's either going to be blue, red, or green, right? That's what it tells us in the beginning. It's either going to be blue, red, or green. So we know that blue is 12 out of 45 in this trial, and red is 21 out of 45. So green would be the other outcomes. So out of 45 times, we're going to take away the 21 that were red and the 12 that were blue, and that's going to leave us with 12 more times in which we got green. So we got green 12 out of the 45 times. So again, where that's coming from is that it was either going to be blue, red, or green. So if I know how many times it was blue and I know how many times it was red out of our 45 trials, what's left over is the amount of times it was green. All right, so now that we know our probabilities for getting blue, red, or green, I'm going to go through and say which statement is about the likelihood of green is true. All right, so choice A says green is just as likely to occur as red or blue. Well, green is 12 out of 45, blue is 12 out of 45, so those are just as likely to occur, but then red is 21 out of 45. So because we have the bigger numerator, that's going to be more likely to occur. So choice A is out. Green is just as likely as blue to occur, but not as likely as red. Well, that's basically what I just said. Green and blue are both 12 out of 45, but red is 21 out of 45. So that's very much more likely to occur. So I'm going to say that's probably my answer, but I'm going to go through the other ones just to be sure. Green is not as likely as red or blue to appear. Well, we know green and blue are equal likely chance. They're both 12 out of 45, so that's out. And then green is not as likely as blue to appear, but as likely as red. Well, green and blue have the same probabilities, red is different, so that's out, and it's definitely choice B. All right, for our next one, a spinner is divided into 4 colored sections that are not of equal size. So what's important about that is that means that the probabilities of them occurring are different, right? With my probabilities of rolling a die and landing 1 through 6, those are all equal probabilities because they have the same chance of occurring. But if I have different sizes, then landing on it, there's a more likely chance for one way or the other. So they're not of equal size. So we have this spinner divided into 4 colored sections, not of equal size. We have red, blue, purple, and orange. The arrow on the spinner is spun several times. So we see that the number of times that we rolled or spun a red was 15. The number of times we spun blue was 24. The number of times we spun purple is 12. And the number of times we spun orange is 9. So just by looking at that data, I'd be inclined, without having seen the spinner, to say that blue is probably a bigger section and maybe orange is a smaller section, right? It occurred less to get orange, so it's probably a smaller space that it would land on, and blue maybe is a bigger because it occurred more. So the arrow of the spinner will be spun one more time. Based on these results, what is the probability that the arrow will land on the purple section? So we're looking for the probability of purple. So I want to know how many times that could occur, right? So number of times it could happen over the number of total outcomes. Okay, so the number of times that it could happen, well, it happened 12 times out of our total number of outcomes. So I'm going to add up 15 plus 24 plus 12 plus 9 to get a total of 60. So 12 out of 60. So my probability of landing on purple would be 12 out of 60. But if I look at my answer choices, none of those match that 12 out of 60. So I'm going to say, well, maybe I need to reduce this. So I can divide both 12 and 60 by 12, right? So divide by 12 to get 1, divide by 12 to get 5. So our probability is 1/5. You could also determine that 12 over 60 is the same as 1/5 by dividing on your calculator, 12 divided by 60 and 1 divided by 5, to see that those two things are going to be equal. All right, so one more question here. A passenger train has tickets available for 12 window seats and 8 aisle seats. The next person to buy a ticket will be randomly assigned to one of those seats. What is the probability that the next person will be assigned an aisle seat? So we're looking for the probability of an aisle seat. So how many times this could occur? Well, there are 8 aisle seats out of the total number of outcomes. So I could have been assigned a window or an aisle seat. So the total number here being 20 seats. So I have 8 out of 20. Again, does not match any of my answer choices exactly, so I have to maybe simplify. So I have to look at what would both 8 and 20 be divisible by, and I can simplify here by dividing both of these by 4. 8 divided by 4 is going to give us 2, and 20 divided by 4 is going to give us 5 to get a probability of 2/5. So the big thing with our probabilities, 2 main concepts from today. One is that our probabilities will always occur between 0 and 1. So our probability is always going to be a number, or whether it's a fraction or a decimal, between 0 and 1. Closer it is to 0, the less likely. Closer it is to 1, the more likely. Secondly, we can calculate our probabilities by always looking at the number of times that something could occur out of our total number of outcomes, right? So we're looking at how many times we got specific thing that we're looking for, right? So in this case, the probability of the aisle seat. So we had 8 possible ways that we could get an aisle seat out of our total number of outcomes, which would be our total number of seats. There's 20 seats that we could have picked from. So it's the number of times that something could occur, and then our number of times that we have our outcomes for our total probability here. All right, hope you guys enjoyed today's lesson. Bye.